Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility, so this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
Super. Today's focus incident we're going to be looking at is Azure Kubernetes Service, or sometimes we call it AKS. This is an issue where customers who are using a new Ubuntu image, it had a security feature that we actually added, and it caused passwords to auto-expire after about 90 days. Once this password expires, new nodes couldn't boot. So whenever customers try to do a scale operation or create a new operation or a restart, the operation would have failed. Now, already running Kubernetes services were fine. Scale down was fine, but anything new would have had a problem.
That's right. That sounds like a big deal. That sounds super impactful for customers. So I'd like to introduce a couple of engineering leaders joining us on our panel today. On to my right-hand side, we've got Brendan Burns. Brendan is our Corporate Vice President from Azure Cloud Native and Resource Management. Thank you for being here, Brendan. We've also got Yi Wang. Yi is our Principal Software Engineering Manager representing AKS specifically. Very good.
Brendan, can we perhaps start with you? Microsoft as a company has been really public about how we're prioritizing security. And I was wondering you could walk through how Kubernetes thinks about security and how we think about how we adopt those principles and apply them to the Kubernetes service.
Sure. I mean, I think one of the first learnings that I was taught about security is that it's a journey and not a destination, right? And so what that means is we're continuously modifying and making changes to improve the security posture of the Kubernetes service in AKS, and that includes, how we configure Kubernetes, how we configure the components that we deploy into the cluster, and in this particular case, how we configure the operating system that is running for the machines that are part of the cluster. And obviously, as a part of that, we consult with people across the industry to understand what the best practices for security are. And so that's a mix of our own expertise, the expertise of the open source community, and in this case, the expertise of standards bodies that set things like the CIS standard for what security means on an operating system. And that's important because security is definitely about securing the service, but there's also a number of scanners and security solutions that our customers use, and so we want to make sure that we are matching the best practices that those scanners are looking for, so that when their CISO looks at a report, a cluster that we believe is secure is a cluster that the scanner vendor believes is secure as well.
All right, super
cool. That's great to understand kind of from that initial posture. So Yi, maybe we'll bring you in here. Let's fast forward to the incident itself that started on the 22nd of January. What did that feel like for customers? Like Sami gave us a brief overview there, but what would customers have felt? What would they have run into? What errors or symptoms would they have seen? And would they have known why initially?
So on the day of the incident, the customer will be fail on their all scale up operations on their AKS clusters, meaning they are not able to adding new nodes into their clusters. So then if they have a heavy traffic during the time, so they will not be able to offload those traffic and then maybe feeling like, say, application failures. So then we initially just detecting this issue by one customer raising this incident to us. And then meanwhile, we have been detected over the quality of the service of the scale up operation has been dropped. And then we analyzed the problem, and then we're seeing this is caused by the password expire issue on the VHD, which is running by the custom script extension. And then we just immediately going in and then fixing over services, which is serving the CSE script, and then to just scripting out that the expiracy of the password. And then so then they are for any customers who is trying to creating a new agent pool will be unblocked from the issue.
Got it. That's how we were able to mitigate it. I do think, Brendan, we kind of fast forwarded into like how we were fixing customers. Would you give us a little more about how we broke them in the first place, right? Like you mentioned CIS and the industry standard. We thought that this password expiration feature sounded like a good idea. Maybe we didn't have a full understanding of the implication it would have.
Sure. I mean, I think that there's two aspects. One is like CIS and other standards are basically checklists, right? And so as you're going through that, you sort of just go through the checklist and make sure that all of these things are applied to our images, and we are sort of constantly doing that to improve our the report that comes out when you run the CIS scanner on our machines. In this particular case, one of the things was to say, hey, the root password, so the password for the administrative user on the machine, should expire after a period of time, and that's intended to make it more difficult for those credentials to be exfiltrated and things like, if they happen to be exfiltrated, they'll get rotated at a certain point. I think what we didn't necessarily think about was if that user was being used as part of the setup of the machine, and it turns out, in fact, it was actually being used as part of the startup and the setup of the machine. So it wasn't the expiration exactly that was the thing that failed. Mm-hmm. It was the combination of the expiration and then an action attempting to be taken as that user, which then failed because the password had been expired. And so I think we both didn't necessarily think about the specifics of what the security hardening was trying to achieve, because actually the CIS standard has actually changed over time. But then also we didn't understand that we had this kind of dependency between a script that we were running and this root user, and that's ultimately what caused the problem.
So, Super, when you were describing kind of the how you detected and so on, it sounded very elegant. The fog of war has closed now. But hearing what it is, it's a unique set of combination of things that have to line up. And we detected this, you said, did we detect it, but we know that customers raised issues. How do we go back and trace it back to an update that applied for something for 90 days old? And then how do we go about mitigating something like this? Like looking for our overall response, how do we go about it when not everything was known? It wasn't an update that happened yesterday.
Yes. So we actually looking into the customer's failing operations, and then we got the specific error messages for, like, say, the password of the root account has been expired, and then we correlate back to all the current failure messages, which is all pointing back to one certain version of the VHD we have been released. And then we correlate back into that specific release of that VHD version, and then we found out we have been included a new change, which is adding the password expiry date. So that's how we pin that problem out. And then for how we are fixing for the customer, we immediately going in and then to fixing the service, which is serving the script to the clusters. And then we just remove the expiry date of the password. So then, like, say, once the customer's clusters getting this update for the new scripts, and then their problem will be gone, and then their skill operation will be unblocked immediately. So that's why we're initially initiating comms to the customer, and then say for the customers who wants to do the mitigation right now, and then to get rid of the problem, so they can initiate a node image upgrade, and then to upgrading their script, so then they will be having the problem mitigated immediately. But there do have certain customers still have this impact, but they're not in the immediate action of doing the scale up at the time. So then their existing operations is not impacted. So then they're having potential impact in the future, which is they are kind of like not really eager to running a heavy node image upgrade at the time. So then they have been instructed us, like, say, do you guys have any other alternatives to be mitigating this issue for a future impact? So that's where we're looking into from the service side, and then we're hot fixing our services to be providing alternative mitigation, which is we can apply this fix to the customer's cluster directly from the server side without any customer intervention.
All right. So they weren't running out of road, but they might be in 5, 6, 7, 8 days time, and so that's when.
Exactly.
Okay.
Yeah.
So that's the split that I just want to kind of double click on a little bit, because we provided this as basically a workaround during the issue. We said to customers, if you need to go and do this, here's how you can do this. But I think some customers were confused a little bit because we mitigated the issue and then we reactivated it. I just want to understand that's because we had it mitigated by explaining to customers how they could unblock it.
Yes.
And then we reactivated and kind of took another look at that and decided we could fix it ourselves on their behalf.
That's exactly the case. And then I think that's also depending on the actual customer need at the moment, because there are certain customers, for example, for the customer initially raising the incident to us, so they are under the pressure to be scaling up new resources to their cluster immediately. So what they are looking for is immediate mitigation. So that's why we're giving, like, say, hot fixing the CSC script service, and then to giving customers customers the guidance to be, if you are running a node image upgrade right now, your problem will be solved, and then immediately you could be scaling up new nodes immediately. But there are other customers who are not in the immediate danger of, like, say, running into the problem, but they have thousands of clusters to manage. So it's not reasonable for us, the customer, to running node image upgrade on every single clusters, and then within, like, say, in the next week. So then we are taking that feedback from the customer, and then we're just looking from the server side to be able to fix for the customer, like, without customer any intervention.
Yeah, I think it highlights a really interesting sort of thing that we don't always talk about, which is, we think of an outage as being like a green dot or a red dot on the status page, right? It's very binary. And I think in this case, we're illustrating the fact that, like, clearly if a customer is impacted, it's an outage. Clearly, if their service that they're trying to run is not working correctly, it's an outage, right? But if they might be impacted in 3 days, is that a red dot on the status page? Is that a green dot on the status page? Is it we will want to have fast incident response. So we want to have an outage declared on our side because we know that there's a potential problem and we need to, work 24/7 until there's a solution. Does that mean we calm it back out as reactivated? It's hard to know. I think probably you want to at least communicate to the customer to say, like, hey, there's this danger lurking out there. We're going to be taking action to try and fix it, so that they're aware of the potential risk. But I think it shows that the notion of an outage isn't necessarily this green or red thing, but it's a little bit more of a continuum.
As we think about what we learned from this outage, it was great that we were able to provide this one-off, say, hey, this is how you get unstuck. And you mentioned for customers, that's great for onesie, twosie. If I have thousands and I need to deploy the scale and policy, I'm going to rely on Microsoft to do this. Is there anything that we learned wider about how we can mitigate this type of thing with AKS again? Are these things, are they common? Are they uncommon? Are we dependent on other images or as the rules of the CIS? Like, how are we managing all these learnings and how we apply our policies at scale?
Well, I mean, I think there's the one learning that I would bring to it is that, I think it took a customer basically complaining to us about, hey, I can't do this at scale, for us to move to do an at-scale solution, right? So I think one of the learnings going forward is we should probably always be doing both. Let's give the instructions to mitigate impacted customers as quickly as possible, but then also let's move to the at-scale solution. I think it's compounded, and we'll cover this at the end a little bit, but it's compounded by the fact that, like, if you were on node auto upgrade, we didn't have to take an action. We wouldn't have had to take an action. Okay. We wouldn't have had to, like, do work behind the scenes to hot fix it and mitigate it for you. And so, at some level, we would suggest that everyone should be on auto upgrade. And so we're sort of taking special out of band, not normal activity to hot fix it for people who want, in this one case, for us to fix it for them, but who in general don't want us to auto upgrade their nodes for them. So there's some interesting nuance there that we're learning about.
A quick follow-up question. I know with everything in IT, there's a trade-off. What are the trade-offs? Why would a customer not want to be on auto upgrade? I mean, you sold it to me, say this great, this sounds like a solution, but people opt out. Why?
Sure. Well, because I mean, the truth is, of course, every once in a while, and we try and make this as rare as possible. And obviously, the goal is to have it never happen. But every once in a while, an OS upgrade breaks you.
Okay.
Right. Maybe it's because it contains a new kernel, and that kernel has a bug in it. Okay. Maybe it's because it includes a new version of a command line tool and the flags that you're calling have subtly changed, right? Over my course of time in the industry, I've seen a number of these, like, it's a patch update from 0.0 to 0.1, like literally nothing could possibly have changed, and oops, we broke everything. Okay. Right?
In this case, it would have saved you, but sometimes it can break you.
Right, and so I think the argument is that in general, auto upgrade is going to fix you more times than it breaks you. Super. Right? But there are people out there who are paranoid, or I shouldn't say paranoid, it's sort of judgmental, but who have a different perspective, right? And who want to be at the keyboard. And a little bit of it is also the being at the keyboard part. I want to know that the upgrade is happening. I want to be sitting there watching my system while the upgrade is happening. And of course, we offer things like maintenance windows and things like that to try and help provide both auto upgrade and the ability for you to know that it's about to happen. But there are still people, who want to be at the keyboard. But I think over time, as we do more auto upgrades, as people gain more confidence in auto upgrades, people are more comfortable, taking that box on. And then, of course, also when people see the toil of things like security updates, right? Like auto upgrade takes away that toil, right? So there's other trade-offs, other advantages that people get out of the system as well.
And to add to that, there are some other legit reasons a customer choose to not opt out for the auto upgrade. And then there are some rare cases that some customer running certain applications require special dependencies on the node image. And then, especially when the Kubernetes versions are upgraded, or some versions of the node image upgraded from one kernel to another new kernel version, so certain dependency might be changed. And then some customer might run into the risk of, what the dependency has been changed, and then their application will be functioned differently. So then for those customers, they are going to be requiring a lot of testing cycles into the upgrade before they can move on to the next new version. So they are not able to accept, we are automatically upgrading either the Kubernetes version or the node image on their behalf and automatically. So that's another, a major reason for a lot of customers opt out for the auto upgrade.
Yeah. That's great to understand that we talked through kind of some options for depending on the customer and depending on the scenario, here are the pros and cons associated with it. And Brendan, I liked what you were saying about our learnings and repairs in terms of, do we provide the workaround, do we fix it ourselves? But both of those are reactive, right? That's after the problem's been introduced. I'm sure what a lot of customers watching and interested to hear about our learnings and repairs want to take from this is, how do we avoid getting into this situation in the first place? How could we have avoided, making this change around the password exploration and avoided breaking people in the first place? It's a harder question.
Yeah, I think in this particular case, it's a much harder question because, it's one thing if we introduced a break and it broke immediately, right? We have safe deployment, we have a bunch of testing. I think at this point, I'm fairly confident that, if we had broken scale out and broken it immediately, our built-in testing would have caught it, right? But obviously, our customers expect us to roll out upgrades quickly, right? And so if we waited and we sort of soak tested it for 90 days to wait for this password to expire, to figure out that it's broken, that means we're not going to push out a security update for 90 days. That means we're not going to. So there's this tension between how long you wait to see if there's a problem and how quickly you can roll out new software. And so in this case, where there's a lag between the cause and the effect, it can be very difficult to check. Now, in reality, there's this other aspect, which is we didn't understand there was a dependency. Right? So we didn't understand that there was a dependency between this root user and a particular script. And I think, actually, we probably assumed that there wasn't. Sure. And so sometimes one of the learnings that we have is that we need to codify those assumptions and write them down and figure out if what we're doing actually matches the assumptions that we're operating with. And so I think that's another good learning here is to be able to audit and say what are the users we're using, right? Yeah. What is the systems that we're doing, and that potentially could have helped catch this one. And then on the detection side as well, I think we should probably we're going to continue, as you said, to work on anomaly detection and trying to figure out correlations where, in this particular case, it was a date-based correlation. If we could see hey, clusters that were created at this particular date, the failure rate for scaling up is suddenly 100%. Right? That's a pretty strong signal that we could have used. But of course, there's so many different dimensions that you could try to correlate across. It becomes a little bit tricky to understand.
I really want to touch on that because so often after outages, we hear engineers say, we're going to improve monitoring, or we're going to add this class of monitoring. But it comes with a lot of noise, and it comes with a lot of baggage. And I think that from what I've been learning, the way we create strong SLIs with automated rollback or automated mitigation is to have clean signal. But when we adding monitoring, getting that signal to noise ratio is tough. And then hearing about this unique set of circumstances that had to line up with a certain image with 90 days and scale up and so on, and of course correlating it with all the deployments that are going on in the meantime. How do you strike that balance of signal and noise?
Well, I think the interesting thing here is there is no more monitoring that we should add.
Okay.
Right? We have the monitoring in place. We monitor scale up, quality of service. Okay. What we need is, or the thing that would have found things is the correlation that takes it from, hey, scale up had a 0.1 drop in quality service, or small drop in service, because if you look at the broad set of people doing scaling, the numbers that are failing are quite small. And then effectively reducing that audience down to, as I mentioned before, hey, all clusters that were created 90 days ago on this particular date, if you look at their scale-up costs, it's 0, right? And so how do you figure out how you sort of cohort people? And that's a pretty weird cohort at some level, right? Like all clusters created on a certain day. I mean, that's not necessarily, it's not a particular customer, it's not a particular kind of hardware, it's not, a lot of the dimensions that would otherwise have caused other problems aren't that. And so how do you either have an automated system that can discover those things, or how do you have a list of like, well, if we slice it this way, what's the failure rate? If we slice it this way, what's the failure rate? That's the kind of thing that's necessary. But much like I mentioned, security is a journey in the beginning. I think anomaly detection and anomaly detection systems like this are a journey as well. And so we're constantly both doing things on our side, but also working with centralized teams that focus specifically on anomaly detection broadly. Like to improve their ability to discover this kind of signal that's hidden in the noise.
Right. That's cool to understand the different ways of slicing and dicing it, and of course we're not talking about a human interacting with a table. We have AI to help us kind of analyze some of those signals.
Exactly.
I liked at the very beginning you were talking about CIS and the standard and us striving to move towards that. But based on this conversation, it sounds like you're saying we didn't have a full or thorough understanding of the implications that would have.
Right.
It's not necessarily that we were disagreeing about the right way forward. Has there been any evolution from CIS in terms of what good looks like in this space?
Yeah, I mean, we wouldn't disagree. We don't disagree with this whole idea of passwords expiring being a. We don't think that's a breaking change, right? Although I would also say that what we've seen in the more recent versions of CIS is that actually they've focused a little more on the intent. Sometimes these standards are very prescriptive, and what they're trying to achieve is hidden.
Sure.
Right? What they're trying to achieve is if your root password is compromised, how long does the impact last, right? But they don't write that down. They write down, expire the password at this time frame. And so actually in this particular case, they've now loosened that guidance a little bit and actually gone back to where we were before, which is if root has no password, nobody can log in as root, period. And that's actually a more secure place to be. And so I think that's part of it. But again, I think it's worth understanding that even with this password expiration change, if we hadn't had a script that relied on that user, we wouldn't have broken anyone. Right? And so it's really, I think the password expiration in response to the CIS benchmark was the cause.
Or at least the trigger condition.
It was the trigger, right? Yeah. But the cause was this dependency that we didn't understand. And I think that's the piece that I think is worth understanding, so that in the future, what I think, honestly, every outage I've ever been in, I feel like what we're really trying to understand is these dependencies that we don't know about, right? Practically every outage, I always tell people, nobody wakes up in the morning and is like, I'm going to roll out an outage today. It comes from a connection that you don't understand, a dependency that you didn't think about, and a change. There's no way it could impact over here, and it does.
Yeah, yeah, well said. That's really cool to understand. I mean, I feel like we've covered a lot of different areas here from AKS and to understand the different architectural components here. What about from customer communications? How did we do? Did we keep customers up to date during the outage?
So when this happened, it took a little bit of time. It took a customer raising the issue for us to kind of leap into action. And so the first communication that went out took about 2 hours. Now, as you alluded to, who's impacted? People who are impacted tomorrow, in a day, in a week. And so communicating to the right scope of people took a little bit of time. And in addition, we were, because of the kind of mitigated with the workaround issue that we had and then reactivating it and then doing that, it was a bit stop-starty for customers. I think in general, a lot of the time when customers run into these control plane issues, a lot of the time we have Brain, which is our AI ops system communicating to customers. So customers will try and create or scale a resource. They'll get a thing saying, hey, it's an Azure problem, not a you problem. You don't need to go and change your configuration, your ARM template or anything like that. It's on us. But we're looking, and we don't have dates for it, but we're looking to say, instead of customers failing an operation and then 5, 10, 15 minutes later getting a communication through Azure Service Health, why can't we present the customer with the issue in the error message? So instead of ARM saying, X 100 error, we can say it's an us problem, not a you problem, and we can put workarounds in there instead. And again, there's a little bit of work to do with the ARM team in order to get those kind of those messages out there and being able to edit those so that customers get them in real time. But as we look forward, the way that we do communications today, particularly for control plane, is I think it's unhelpful for a lot of customers to experience an error and then being told that they've experienced the error afterwards. There are times when we want to go broad, and I think this would have been a great time to say, hey, in a day or two, you might run into an error. Here's a workaround. We're working on a long-term mitigation. But for most control plane outages, we really want to get to point-in-time failures.
Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.